All right, for this probability question, we have 500 total people surveyed. We know 77 wanted neither, so we're going to subtract that from the total to get 423. In order to fill out this Venn diagram, we're going to need to think about this formula. It says the probability of A union B equals probability of A plus the probability of B minus the overlap. We have probability of A and probability of B, and we have the union. Because if 77 is on the outside, 423 has to be somewhere inside here. So I know that 423 out of 500 is equal to the probability of A, which is 205 out of 500, plus the probability of B, which is 387 out of 500, minus our missing number, which is our overlap that goes in the middle here. So we're going to solve for that missing piece. So when I add these up, I add the tops together. So I have 205 plus 387. I get 592. And since all of my denominators are the same, I can go ahead and just get rid of my denominators. And I have this problem. Oops, this is a minus sign. I'm going to subtract 592 from each side. I get 169 is equal to x. So the number that's going to go in the middle is 169. I know that this total circle is 205. So I'm going to do 205 minus the 169, and I get 36 there. And then over here, I know the whole circle is 387, so I'm going to do 387 minus the 169, and I get 218. So I filled in my Venn diagram. That was the first step. Probability of hot dogs only is 36 out of 500. What is the probability of hot dogs and pretzels? That's the intersection. 169 out of 500. Probability of hot dogs or pretzels. So I'd be doing what I did earlier, the 423. And then I have E, what are the events, hot dogs and pretzels independent? The answer to that is no. Explain using your shown work. So we'd have to do one of the tests. So one of the tests would be the probability of the hot dogs intersecting the pretzels. Does it equal the probability of the hot dogs times the probability of the pretzels? So this intersection is 169 out of 500. I'm trying to find out if that's the same as 36 out of 500 times 218 out of 500. So if I multiply those together, I do not get the same value. So they're not equal, so they're not independent. Next, I have a basketball player will make a layup when they are fouled 68% of the time. When a player is not fouled, they make a layup 95% of the time. Players are fouled 36% of the time when going up for a layup. Complete a tree diagram. So I got fouled, or I'm not fouled. Actually, let me write this a different way. I'm going to write this on another piece of paper. So, tree diagram. Fouled, not fouled. This is 0.36. This is 0.64. Okay, and now we have to decide, do they make it or do they miss it? Do they make it or do they miss it? And we're going to do this based on what they say in here. It says a basketball player will make a layup when they're fouled 68% of the time. So 0.68 goes here. So then I take this away from 100 to get 0.32. And then my other piece of information, when a player is not fouled, they make a layup 95% of the time. So 95% goes here, or 0.95, and 0.05, because I subtract that from 100%. That's my tree diagram. So we're going to use the tree diagram to help us answer some questions. What is the probability of making a layup? Probability of making a layup, I'm going to have to do, this is how I can make one. So one way to make one is this times this. Another way to make one is this times this. And I'd have to add those two things together. So I'm going to have to do, for part B, I'm going to have to do 0.36 times 0.68 plus 0.64 times 0.95, and that's going to give me, if I round, 0.85. Okay, that's part B. What is the probability of not making a layup is part C. So there's two ways to not make a layup. This one, which would be this times this, and this one, which would be this times this. So I'm going to go 0.36 times 0.32 plus 0.64 times 0.05. And if I round that one, it's going to be about 0.15. Part D, are the events making a layup and being fouled independent events? Explain and show your work. They're not independent. And you can pick any of those choices that we talked, any of those ways that we talked about to prove that.